protective equipment and experiment equipment. Professor A, working at a well-known university in America, visited the laboratory to look over the researchers' experiments before heading home. Professor A, who was observing the experiments close up, was intrigued by the liquid nitrogen stored nuclear magnetic resonance (NMR) tube, and picked it up to observe it. That instant, the liquid sample in the tube immediately vaporized and exploded. During this accident, a part of a glass flew into Professor A's eyes. Professor A lost sight in one of his eyes. So what was the cause of this accident, and what are some safety rules that could prevent similar accidents? This lesson's learning objectives are 1. Be aware of personal chemical protective equipment and safety equipment. 2. Understand chemical experiment, equipment, and accident prevention. For this, you will learn types of harmful substances in each type of lavatory. Personal chemical protective equipment and safety equipment and chemical experiment, equipment, and accident prevention. Are you ready? Let's start! One of the things that immediately comes to mind when you're in a chemical lavatory is the presence of chemical substances. Let's discuss a number of chemicals regarding the types of hazardous substances to be aware of each lavatory. First, in chemical and chemical engineering lavatories, there are various chemical substances, such as organic solvent, acid and alkaline solution, oxide materials, catalytic materials, resin, heavy metal particles, and polymeric monomers. In biological and medical lavatories, there are bacteria, fungi, viruses, pathogens in blood, insects, plant, substances such as preservatives, and liquid nitrogen, which is used for cooling. In physical and mechanical engineering lavatories, there are noise, vibration, high temperatures, low temperatures, ionization beam, lasers, non-ionizing radiation, and oil solvents. Each lab mainly carries out tests using different chemicals that can vary due to the use of different harmful substances. Chemical and chemical engineering lavatories can cause cancer by long-term exposure to chemicals and have bad effects on organs such as the liver, kidneys, and can cause disorders and even infertility in men and women. Biological and medical lavatories cause primarily chemical side effects due to chemical exposure, inflammation, due to secondary infections by pathogens, and irritation and damage to skin, eyes, and upper respiratory tract. Physical and mechanical engineering lavatories can cause welding fume fever and hearing loss induced by noise. When using the machine tools, injuries such as penetrations, cuts, and slicing can occur, and cause insomnia, carpal tunnel syndrome, burns, conjunctivitis, and cataracts can occur. Harmful substances can differ depending on the lavatory used to perform specific tasks or the types of chemicals handled. It is very important to choose the appropriate protective equipment. In order to prevent bad effects caused by harmful substances, we use the protective equipment. First, let us look at respiratory protective equipment. Breathing is the path by which lab workers allow the flow of dangerous and harmful substances into the human body. Therefore, frequent injuries are related to breathing. When we wear appropriate protective equipment, it blocks the exposure of the contaminated air and harmful substances and prevent damage. To manage the respiratory protective equipment, be sure to take compatibility tests every year. Laboratory workers are familiar with the methods of use in advance and are sure to prepare storage in a clean place. There are two types of respiratory protective equipment: the air purifying respirator and a supplied air respirator. First, the air purifying respirator removes contaminants before they are sucked into the respiratory apparatus. After the contaminated air passes through the filter medium or canister. There are two types: the hand-operated and the powered types. The hand-operated type is inexpensive and is a personal product. It is also uncomfortable to wear and tight. The powered type is expensive but comfortable to wear, and it can be used with contaminated air at higher concentrations than those in the manual. They cannot be used where the air density is lower than 18%. In such a case, use a supplied air respirator. Supplied air respirators can separate hazardous air from the air supply pipe, and are respirators with an air hose or air source would suck only the fresh air. They can be used where the air density is lower than 18%, or when the concentration of harmful substances and the toxicity are high. If we don't know the type and concentration of the harmful substances in the workplace, we wear special respiratory protective equipment. Click the button and check the classification of the respiratory protective equipment. Commonly used respiratory protective equipment in the lavatory includes the filter-type mask, the hand-operated air purifying mask, the powered air purifying mask, the operating mask, and the dust mask. Let's take a look at the filter type of mask. Filter-type masks are used applicants to filter particulate, harmful substances such as asbestos and biological aerosols. They cannot protect lavatory workers from non-particulate, harmful substances such as gas or steam. Filter masks are disposable, and the types vary greatly. Hand-operated air purifying masks depending on the type of cartridge, and it is possible to prevent the inflow of very different types of harmful substances when using them. The most important aspect is to select the appropriate cartridge to filter harmful substances. When storing the cartridge, it is important to keep it separately in a clean and dry place. Cartridge needs to be checked on a regular basis and used within a limited time. Powered air purifying masks use a battery for power and consist of a half mask and full face piece mask, a respiratory tract, and an air blower operating on battery power with a cartridge filter. Just like a hand-operated air purifying mask, the cartridge filters the harmful substances selectively, and the selection of an appropriate cartridge is very important. Compared to the hand-operated air purifying mask, it is comfortable to wear and easy to breathe through. In order to prepare for an unexpected accident, be sure to check the charge status of the battery at all times. Operating masks and dust masks are convenient and are the most frequently used types in the lavatory. They can be worn in the lavatory where dust, mist, and fumes are generated, but the respiratory protection is more vulnerable than other masks. Therefore, the user always be aware of the need to use other respirators. When there is a risk of oxygen deficiency or there is a harmful substance in a gas state, absolutely do not wear. The primary purpose of protective equipment for the skin is to protect the skin from a variety of harmful substances. Depending on the types of harmful substances, various types of protective equipment for the skin exist, such as gloves, lab coats, and shoe covers. Harmful substances are chemical substances such as toxic and corrosive substances, physical substances such as lasers and high temperatures, and biological substances such as bacteria and viruses. The selection of appropriate protective gloves to protect against lavatory safety accident is very important. Be sure to wear them when dealing with hazardous or toxic substances, chemicals with toxic, corrosive materials, rough or sharp materials, and hot or cold materials. The materials can vary, such as disposable latex, vinyl, and nitrile gloves, and the selection can depend on the research environment. Prior to wearing them, inspect for abrasion and holes. When inspecting them, absolutely do not use water. Protective gloves that have been in contact with hazardous substances can cause secondary pollution, so be careful when handling them. In particular, disposable gloves must be discarded, and reusable gloves stored in a dry condition after washing. Considerations when selecting protective gloves are the reducing degree of protection performance and permeability. The reducing degree of protection performance means that after contact with chemicals, the degree of loss of the unique nature and the decrease in the protective performance by, for instance, expansion, shrinkage, curing, and decomposition. Permeability refers to the elapsed time on the surface of initial glove from the inside of the glove after chemicals come into contact until the material is detected. Therefore, depending on the characteristic of the experimental to be executed, select protective gloves capable of suitable performance. These are the considerations with regard to protective gloves material. Butyl rubber is the most suitable for highly volatile esters and ketones, but is sensitive to gasoline, halogenated substances, and hydrocarbons. For neoprene, the tensile strength, heat resistance, and wear resistance are excellent and suitable when dealing with acids, corrosive substances, and oils. For latex, the elasticity and resistant are excellent and can be used with a diverse range of chemical substances, such as acids, corrosive, salts, and alcohol. This material is vulnerable to organic solvents and can cause allergic reactions. Nitrile is typical substance of disposable protective gloves and is often used in the lavatory. It can offer resistance to various types of chemical substances. It is suitable for lavatory workers who have an allergic reaction to latex. We can consider it to be an appropriate material because it is created in a variety of thicknesses. Protective clothing must fit well during research activities, and it is important to wear clothes that do not leave areas exposed. If there is a possibility of contamination from harmful substances, be sure to wear the physical and chemical wear protective clothing to protect the body. Protective clothing is selected appropriately depending on the location and purpose. Disposable protective clothing is used when handling hazardous substances in animal and biological experiments. Disposable clothes usually have an antimicrobial treatment or a way to stop the absorption of a liquid. If a small amount of chemical is attached after use, discard with normal trash. If it is hazardous substance, discard separately. Fire protective clothing does not burn in a fire. It can be used when handling highly reactive substances. Note that fire protection function is extinguished at the time of washing. General protective clothing is mainly used at the time of general experimental operations. It has a certain degree of fire protection power, but it is not perfect, so be aware in advance. General protective clothing is available for use lasting more than 1 year, and it needs regularly washing. Always wear shoes to protect the toes when are using the lavatory and chemicals. Shoes with holes, slippers, and sandals are inappropriate because they can be exposed to hazardous substances. It is possible to prevent accidents due to corrosive and hazardous substances by wearing shoe covers or boots, which are resistant to chemicals. Not only lavatory workers but also everyone should wear protective glasses in principle when entering the lavatory. Protective glasses protect the eyes from chemicals as well as broken glass, laser or radiation. Prohibit the use of contact lenses at the time of research activities. Glasses are not protective equipment, so depending on glasses is forbidden. A protection mask is to protect the eyes as well as the face, neck, and ears. A protection mask is used if a large amount of dangerous or hazardous substances and glass fragments may be generated. A protection mask is used when dealing with a highly reactive or weak chemical and when using glassware in a vacuum or under pressure. Hearing protector is to protect hearing from noise in physical and mechanical engineering laboratories. There are disposable and reusable earplugs. When using the disposable type, dispose after use, and when using the reusable type, clean regularly. Hearing protection is important to wear continuously when noise is generated. We have learned about a variety of personal chemical protective equipment. Because you cannot be fully protected from harmful substances with only personal chemical protective equipment, recognition is essential to be equipped with safety equipment for protection against accident. Shall we take a look at the eye washer and emergency shower? Laboratories dealing with hazardous substances should provide an eye wash station and emergency shower. The eye wash station and emergency shower are placed at least 15 meters within a reachable distance in 10 seconds from harmful substances. In preparation for an accident, it is always to recognize the position and to know how to use the eye wash station and emergency shower. A hood is an apparatus for eliminating the gas and steam that is generated from a chemical substance. It is good to perform experiments under the hood when dealing with chemicals. Depending on the purpose of the equipment, there are fume hood and an arm hood. Strictly prohibited are the acts of saving and discarding chemicals over a long period of time under the hood. Avoid the act of putting your hand in the hood as much as possible. And when using the hood, wear personal protective equipment. In many of the accidents that occurred in science and engineering laboratories related to chemicals, the cause was a lack of an accurate understanding of the nature of the chemical substances prior to the experiment. There are various chemical experiments and equipment, and it is impossible to identify all cases. Let's talk about how accidents can occur in typical chemical-related experiments and the related equipment prevention measures. Distillation is an experimental technique used to purify and separate liquid mixtures through differences in boiling point. Because distillation experiments take place when heating liquids, there is a possibility of accidents related to the thermal properties of the liquids. First, there is a glassware explosion risk due to the increased pressure of the generated steam and a risk of fire from the heat. There is also the risk of lavatory pollution and leaks of heated chemicals. There is a burn risk through the bounce phenomenon due to overheating and due to hot steam or liquid. Because distillation experiments take place while heating a liquid, there is a possibility of accidents related to their thermal properties. It is important to prevent accidents. Use boiling tips to prevent the bounce phenomenon due to overheating. Supply cooling water smoothly to prevent overheating. If the glassware is damaged, you can be injured by debris. Therefore, prohibit the use of damaged equipment. During experimental work, it is very important to maintain an appropriate work environment with protective glasses and protective clothing. The task is heat-related, so until the completion of the experiment, leaving your position is absolutely not allowed. When it is necessary to remove an organic solvent from a reactor, remove it using an evaporator or a vacuum pump. Accidents associated with the use of an evaporator or a vacuum pump may occur. There is a potential for inhalation of harmful substances in the process of removing in a solvent. When using a vacuum pump, one is more likely to be frostbitten when using a low-temperature coolant such as liquid nitrogen. Potential mechanisms can explode due to the use of liquid nitrogen. To prevent an accident, complete the experimental work under the fume hood to minimize exposure to toxic substances, and wear low-temperature protective gloves to protect against frostbite. A method for separating a specific substance from two or more substances. Accidents associated with the various organic solvents may occur. There is the possibility of an explosion when using volatile solvent. There is the possibility of harmful substance exposure when not using care during the extraction process. To prevent an accident, do not work before the process falls below the recorded boiling point during the extraction process. At the time of the mass use of organic solvents, be careful about the outflow. When various solvents are used, wear the appropriate protective gloves, protective clothing, and protective glasses. GC and HPLC are the equipment to be detected by separating the mixture of liquid and meteorological. The main cause of the accident is the immature use of equipment. Before using the equipment, fully understand how to use the equipment. In the process of handling a liquid solvent, safety accidents caused by suction or glass shards of hazardous substances through the exposed. Through the use of vacuum pump, safety accidents can be generated. There is the possibility of gas leakage when using GC in accordance with the mobile phase gas used. In the analysis process, there is a possibility of burns can be generated through the high temperature operation. To prevent an accident, fully understand how to use the equipment and rehearse the use of the equipment, and use appropriate protective equipment. If you're not familiar with the equipment, always work with an expert. The possibility of an ancillary safety accident exists, so always check the status of the lavatory and the research environment. A centrifuge is a device which utilizes centrifugal force, permitting separation according to the density difference between a solid and a liquid, or between a liquid and a liquid. Accidents associated with a centrifuge may occur, because the centrifugal operates at a very fast rate. It is not balanced and the bounce phenomenon may occur. Due to the shock of the bounce phenomenon, it is possible to be injured. To prevent an accident, fully understand how to use the equipment and rehearse the use of the equipment and use appropriate protective equipment. If you're not familiar with the equipment, always work with an expert. Before use, balance the weight of the internal sample. Around Raman Spectroscope is a type of spectrometer instrument, an experimental apparatus used to determine the type and state of a substance. Accidents can be caused by the careless use of the device. There is the possibility of damage to the eyes due to laser exposure and burns of the skin due to laser exposure. There is also the possibility of inflammable solvent fires, such as clothing and paper being ignited through laser exposure. To prevent an accident, fully understand how to use the equipment. Use the appropriate protective equipment, especially protective glasses. Protective glasses must be protected from the laser. Through laser contact, a temperature rise of the sample is possible, so do not leave your position.
Okay then, should we take a look at possible ways to prevent the laboratory safety accident in the story?
Danger, in account of what we have learned so far? First, goggles should always be worn in the lavatory in case of an unexpected emergency. Even in this accident case, if the professor had worn goggles, the accident would not have been this big. Also, possible vaporizing explosions must be taken note in an area where experiments are conducted repeatedly in low temperatures and room temperatures. Lastly, lavatory safety accidents can pose a threat to someone not only by his or her mistake, but also by others. Therefore, everybody participating in the lavatory must abide by the safety rules. Please remember that lavatory safety accidents can be fully prevented depending on whether you have followed the prevention rules or not.
Check with quiz to make sure you understand the course.
Did you enjoy the lesson? Remember the knowledge you've learned. In this lesson, you have learned about Chemistry 1, Chemical Protective Equipment and Experiment Equipment. In the next lesson, you will learn about Chemistry 2, understanding the types of chemical substances and GHS and MSDS.